So once you have memorized these three Maclaurin series, remember not Taylor series, you can play with substituting. So let's find the Maclaurin series for cosine of 2x squared. So I substitute in 2x squared. Oops, that should be an nth power. So I substitute in 2x squared and into the cosine, which is the even powered one. And remember, you must put parentheses around those factorials. So let's fix this a little bit before we move on to the next step. So I get x to the 4n all over 2n factorial. Okay, so now I'm going to put this in the integral. So I have the integral and because I'm integrating with respect to x, that's the only thing that's going to have the power increased. So I'm carrying along all the constants. So I add 1 to the exponent, and I put it over that same number and add a plus c. All right, so let's play with e to the 3x squared. So you've got this memorized. So it's 3x squared to the nth power over n factorial. So let's break that up. So now I want to divide through by x squared. So communicate to your reader what you're doing. So I have 3 to the nth power, x to the 2n, n factorial, and then there would be an x squared here. So I was careful to show I'm putting that dividing by x squared on both sides. So now let's join the x terms together. So I get x to the 2n minus 2 over n factorial. Now I'm ready to integrate. So let's put this in the integral. And I'm going to add 1 to the exponent. Oops, what's going on? Collapse, go away, stop, clear, stop. Okay. Sorry about that. Okay, so then I have 3 to the n, x to the 2n minus 1, n factorial, 2n minus 1 in the denominator, plus c. All right, moving on to the last one. So I have sine of pi x cubed. So sine has the odd power, so it's going to be a little longer. So I have pi x cubed to the 2n plus 1 power, and I've got this 2n plus 1 factorial down here. So let's fix this. So I have negative 1 to the n, pi to the 2n plus 1, x to the 6n plus 3, being careful with those exponents. Now I need to multiply this by x. So I've got negative 1 to the n, pi to the 2n plus 1, x to the 6n plus 3 times another x. Okay, so let's fix that up. So I can put it in the integral. So I get x to the 6n plus 4 because I'm adding that 1 to the exponent. So this is ready to integrate. So I carry the constants along. And I'm ready to add 1 to the exponent. Plus c. And we're done.